Welcome to this course on computer vision. I'm Hani Farid. I'm a professor here at the University of California, Berkeley, where I specialize in computer vision, image analysis, image forensics, and human perception. And I'm excited to share with you some of the advances in these fields over the past few decades. In 1966, Seymour Papert and Marvin Minsky, two pioneers of artificial intelligence, launched the so-called Summer Vision Project. They believe that in just a 2-month period, and with a team of just 10 engineers, they could build a computer system that could identify objects in an image. More than 5 decades later, and an untold number of researcher hours, published papers, and billions in funding, basic object recognition is still not considered a solved problem. We may have the sense that vision should, in fact, be a relatively simple problem. After all, we open our eyes every morning and, well, we just see. We, seemingly effortlessly, reason about and navigate in our environment. We recognize our friends and family. We find our car keys, and we solve a myriad of tasks that today's most sophisticated computer vision systems still struggle with. The field of computer vision is largely dedicated to building computer systems that mimic the marvel that is the human visual system. From one or more images, reason about, navigate through, and understand the physical, three-dimensional world around us. Applications of computer vision include everything from building fully autonomous vehicles to automatically detecting and classifying cancer in CT scans, facial recognition that allows you to unlock your phone or tag your friends on social media, and Snapchat filters that add bunny ears to your video. Gaining expertise in this field requires learning about optics, physics, signal and image processing, linear algebra, probability, and numerical methods, and, of course, machine learning. All topics we will cover in this class. Both computer and human visual processing start with the image formation process, in which our three-dimensional world is projected onto a two-dimensional sensor. From one or more recorded image, our goal is to reason about and understand the three-dimensional world. Everything from object recognition to navigation, facial recognition, and more. To accomplish this, we will first start by understanding the geometry of image formation. And then we will provide you with a set of mathematical and numerical tools to analyze and reason about images with the goal of getting us closer to building computer vision systems that can mimic the marvel that is our own visual system. Welcome, and I look forward to our journey going ahead.